So this intro is only for the subscribers. So if you're not a subscriber, skip to like 2 minutes in the video or like tap your screen 12 times to jump there right now. There will be chapters below as well to jump you there. Now that only the realest of the real subscribers are watching, I want to talk about everything that has plagued me with making videos this past week. So first, running out of storage has been a huge issue. Filming these takes a lot longer than you would think in a big single take 4K video, especially filming raw, which takes way too long to edit the color. So we're not doing that anymore. The other thing is my Bambu printer has been malfunctioning like crazy, from wasting almost a whole kilogram of filament to just stopping the print entirely. So that sucks. And don't even get me started on Bambu with their new firmware coming out for 1.08. I'm sure you guys have seen that in the news lately, and maybe I'll make a video on that, but they're locking down printers now, which is a little bit scary. So yeah, not a huge fan of that. The other thing that's been plaguing me with making videos lately is the cables on my SSDs have been driving me nuts. They keep disconnecting, and when they disconnect, your Final Cut just pauses, and then it says, hey, your drive's disconnected, and you lose the last 20 minutes of your work, which has been driving me crazy. So anyways, I got a new drive. I got the Bambu ticket opened. No response yet. It's been like 2 whole days, so who knows. Anyways, first let me check my Bambu printer and make sure it's printing correctly. So today's video is going to be all about the filaments that I would get as a beginner and where I started and why that was a problem. So before we get into it, if you only have 30 seconds to watch this video, start with PLA, jump up to PETG, maybe someday get into ABS or ASA if you have an enclosed printer. And here's why. Where I started was problematic. So when I started 3D printing, I had an open printer. It was not enclosed. It was a Creality, so just your typical run-of-the-mill open printer. It was a bed slinger, as we call it. The bed slinger that I had was a CR10 S5. So with my open frame printer, the first material that I tried to print, which I thought was going to be perfect, was ABS. So my printer came with a roll of PLA. I had printed my benchy in my PLA. I had printed all my calibrations in PLA, and I was like, this is going to go perfectly. We're totally good to go. And then I wanted some stronger prints. So I Googled what filament could be used for stronger prints on 3D printing, and ABS was one of the #1 things that popped up. And I was like, sure, let's do ABS. Keep in mind, this is like 3 years ago. So back then, ABS really was really popular. It was one of the most popular filaments you could get because of the rich colors and diversity of the filaments that were in ABS to begin with. So I bought my ABS, I bought 2 whole rolls, which was my first mistake of ABS that I had never printed with. And I started trying to print, just everyday things. I tried to print a calibration cube. Worked out okay. I tried to print a slightly larger object that was like, maybe that. Oh, actually, no, I remember what it was. It was a piece that went on the top of the printer, and it had a piece where the filament would come in, and the filament would go down to the bottom of the printer. And that became a huge problem because it was about 5 inches long, and it would warp. So it would, if the print was flat like this, it would begin to curve up on the ends. And that caused a ton of problems. That is a big part of ABS filament. So if you don't have an enclosed printer, the ABS will begin to warp because just the environment that it's in has to be hot, like really hot. Like we're talking, it has to be like a sauna wherever your printer is. So if you have an enclosed printer and it's nice and hot, what you can do, heat your bed up, preheat that chamber to, 50, 60 degrees Celsius, and then start your print. If you can get it that high, sometimes like 30 or 40 Celsius might be good enough depending on where you're at. Or you might just live in a naturally hot environment, in which case, got to help you. Anyways, I tried to print with this ABS and it went horribly. I hated it. I was like a month into 3D printing, brand new to this, and I was about to throw my printer in the garbage because I couldn't print anything unless it was PLA. And in my mind, that meant I couldn't get strong prints, and that meant that it was a waste of time. And I was like, this sucks. So I stopped printing for a couple months. That was a huge downfall for me early on. The first like 4 months of 3D printing were just like a roller coaster. So where would I start today to prevent that? And how do you get strong prints without using something like ABS? So where I would start today, start with PLA for the first month, get to know your printer. See what problems you have with PLA. You probably won't have that many. You probably won't have warping issues or layer adhesion or bed adhesion issues. If anything, in PLA, you might only have like retraction issues, speed issues, minor things that you can fix in software. Now, once you've printed in PLA and you've got to understand the properties of PLA, you can start to move on to structural properties of your prints, like how, do I want this print to be stronger? And that could be a couple things. It could be orientation. If you're printing a print that is vertical and then you're going to mount that to the wall like this, it could just snap off because the layer lines go like this all the way down the print. Now, if you print something that is horizontal on the plate and then you mount it on the wall and all the layer lines are going like this the entire time, you're going to try and it's going to try and bend that object, and that's going to be a lot harder to break than if the layer lines went like this all the way down the print where they could just snap in half. Hopefully the hand gestures help there. Maybe I can get like an example on screen or something. So knowing the orientation is a huge part of it as well. So once you've printed in PLA, you understand your printer, you've kind of faced some challenges and got through it in the first month or two. Once you've tested orientation, you understand orientation is a huge deal. Then you can move on to more advanced materials. That's where I wish I would have started. That's what I wish I would have been told when I began this journey. So where you go from PLA is going to change a lot. I also tried PLA wood when I first started. Very brittle filament, may or may not be recommended to new users, so maybe stay away from that one for a little bit. Where I'd recommend going after PLA, honestly, is PETG. Just get a roll of PETG from Polymaker, Overture. I've even tried Ceramic recently, and that's been great. PETG is very strong. It's very flexible. So PLA, if you printed with it for a month or two, you'll realize PLA is very brittle. It doesn't absorb impact as well. PETG, though, is really flexible. You can print a PETG like wall hook and like about bend it before it snaps in half. Where PLA is just as soon as you get too much pressure, it just falls apart on you. With PETG, you don't necessarily need an enclosure, which is why I recommend it next, but you do need a much hotter printer, a much hotter print bed, a much hotter nozzle. If you have a hardened steel nozzle, you'll want that nozzle to be about 10 degrees hotter than a standard steel nozzle. That's another thing I wish I would have known. With PETG, there's issues with layer adhesion. So layer adhesion is the layers of the print need to, stack on top of each other, and they need to have better adhesion with PETG, which is related to the temperature of the nozzle. So if your PETG is too cold, then the print, you can literally pull it in half and it will just break at some seam. Now, if you're too hot, then you'll get a lot of ringing on the outside surface. It's going to be a little unstable. So you really want to get your PETG dialed into like 240C, or maybe 250C if you're on a hardened steel hot end. And what I would recommend doing is a temperature tower where you can do like 220, 230, 240, 250, 260, 270, and like see how that affects the print quality. You can find temperature towers on Printables, MakerWorld, any of those. After you've mastered PETG for a month or two, I would honestly recommend going to ABS or ASA. Now, ABS and ASA have a bunch of fumes, which is something I had no idea about when I first started. It fumed my room up so bad that I would print in the guest bedroom on the other side of the house. I would close that door and I would leave that sucker shut for the whole day. It was that bad. You could open a window in there and it hopefully kind of helped, but the fumes of ABS and ASA are bad. And the problem with them is there's not a lot of science done on how bad they are air quality wise for you. Now, the general consensus is that ABS and ASA fumes are bad for you. Possibly even PETG might have fumes, and even PLA. I have my own story about that, which I will tell someday, but that's not the story. Anyways, I have a lot of stories to share with you guys. So ABS and ASA, the fumes are definitely something you're going to want to filter. An air purifier, if you have an enclosed printer, which you will need for ABS and ASA, by the way, a charcoal filter in there is super helpful. You can print the bento box for the Bambu P1S and X1C, or if you get those little pop-up tents from Amazon, you can also print a bento box to go in one of those. Just make sure it's secured well if the printer is vibrating and moving around a lot. So what I would suggest is if you're going to print ABS and ASA and you don't have a filtration system, really make sure the environment is exchanging air 10 or 12 times over. So if you have a window open, make sure that you have active fans to push air out of that room as much as possible. You want that air to be recycling very fast. That way you do not endanger yourself or others with the fumes from ABS and ASA. Now, the thing with ABS and ASA too, they're going to warp and they don't like to stick to textured PEI, so you'll probably have to make an ABS slurry, which is where you take some ABS pieces of your filament and some acetone in a jar, mix them up in a glass jar, mix them up, and then you'll put that on your bed. That will damage your PEI bed long term. I have done it to my textured beds a few times, probably 5 or 6 times. And each time it has made that textured bed kind of milky white and hazy for the next 5 or 6 prints after. And you end up kind of having the print like an entire sheet of plastic and peeling it off like 6 or 7 times to get that haze effect off of there. And I can only imagine that's damaging the very outermost layer of your PEI bed over time. So definitely get like a sacrificial steel plate for ABS and ASA. And I would definitely recommend like a smooth plate if you can. That way you get better adhesion with a smooth plate with this slurry and in a hot enclosed printer. Those 3 things will make ABS and ASA prints go near flawless. Now, if you get any cracking in your ASA on the layers, that means that it's too cold. Maybe there was a breeze that hit your print. And I'm not even kidding, a cold breeze can cause the filament to crack while it's printing, which is so frustrating. We have a print that I need to talk about in the next video that I printed recently, and we were using ASA, and it cracked like crazy a couple times, and it just drove me nuts. Now, if you do get a crack in your ASA or ABS, or maybe you're using it for cosplay and you do damage it, you can heal it. You can take acetone, put it on a Q-tip, rub it over that little crack, and it will melt the plastic and fuse it back together, which is awesome. So really, to summarize this video in just a couple minutes here, start with PLA, go to PETG, but be careful with PETG with the heat and the adhesion, then go to ABS and ASA, and that is going to require heated printer, ASA slurry, smooth bed, those kinds of things, and then start to learn the properties of the materials. Like ASA and ABS can be fused with acetone. PETG, you can actually use like a methyl ethyl ketone, if I'm saying that right, MEK, which is also a very dangerous chemical, so be careful. And PLA, you could just glue with just about anything, super glue, E6000, and 3D Gloop actually makes a PLA solvent that you can use. From there, you can go anywhere. If you've mastered ABS and ASA, you have mastered the majority of the consumer grade filaments. And what I mean by consumer grade is anything that's not, PEEK or PA6, these more engineering materials. So consumer grade materials would be like PLA, PLA silk, PLA wood, ABS, ABS glass filled, ABS carbon fiber, PETG, PETG carbon fiber, PETG glass filled, these sorts of things. And if you have mastered those, and you can really print just about anything that is just consumer grade. Now, where you get into more advanced engineering materials are going to be those PEEK, PA6, PA12, these filaments that are extremely expensive, extremely difficult to print, or anything that's maybe a little more technical, like continuous carbon fiber is a much more difficult type of material to print than chopped carbon fiber filaments. So definitely be careful with those as well, because carbon fibers can get into the air and affect your air quality as well. So that's my story about where I started with 3D printing and why it was so frustrating going to print ABS on an open printer, not knowing how hard and difficult that actually is, not knowing what ABS slurry is, not knowing how important a heated bed really is, drove me crazy. And now I have a P1S and I can print ABS and ASA just fine. I have it. I have filtration on there. I have the window open as much as possible, and I print it very selectively. So it's very rarely that I print it. But when I do print it, it prints well, with the exception of this one print I was working on recently where I'm just a perfectionist, and I have to talk about that, which is going to be a good video as well. And hopefully I can bring that out to you guys soon. Yeah, that's really all I had. So thank you guys for watching. If you're a new beginner to 3D printing, please let me know, what you've printed in the comments below, what materials you've used, what materials you prefer. If there's any materials I didn't cover in this and you would recommend, maybe you can tell the community about that in the comments so we can get a great discussion going on there, guys. Thank you so much for watching, and I will catch y'all on the next one.